All right. Well, I see it's 1 o'clock, so we will go ahead and get this thing rolling here. I just want to welcome everybody to our Payback for Lubrication Excellence webinar. We're happy to have Terry Harris with Reliable Process Solutions here to present this topic for us. Terry's done really great webinars for us in the past, so we're looking forward to what he has to share with us today. Kind of as part of our lubrication month. So hopefully folks were able to tune in a couple weeks ago when we had Hydrotechs presenting on ways your lube tech can improve reliability. So now this is our next webinar in this series for February, or Lubruary as we've been calling it. And then we've got our last one next week, rather, on Thursday. Adrian Messer with UE Systems is going to present on ultrasound assisted lubrication. So we'll kind of bring it all back to obviously important to us, how ultrasound kind of ties in with lubrication. So just a little bit about UE Systems for those that aren't familiar. You know, for over 40 years now, we've been designing handheld ultrasonic inspection equipment. Folks throughout the world are using our equipment for all different kinds of testing, from steam traps to compressed air leaks, using it for mechanical inspections, electrical inspections, and of course using it to assist in their lubrication efforts. So as everybody who's probably on here today knows how important a good lubrication program can be for your assets, for your facility, ultrasound, can play a role in helping you with that. So we've got offices and support groups throughout the world helping folks use our equipment. So just a little bit about us there. Just some housekeeping before we turn it over to Terry. I am recording this, so if you have to drop off early or you've got a colleague that couldn't make it, we'll have this recording available for you to view at a later point. We also would love for you to ask questions throughout. There's a little questions box, so you can type those into us as we go through the webinar today, and I'll kind of be monitoring those, and we'll get those questions asked to Terry during the session if it makes sense, or of course during the Q&A part at the end. So definitely feel free to toss those questions our way, and Terry will get those answered for you. Hopefully we won't have any technical issues today, but you just never know. So just bear with us if audio drops or we have some kind of issue. We'll try and get it resolved as quickly as we can. But that's part of the doing live TV here. So we like that we get to do these live, but just bear with us if any of those things happen. That's sort of my little disclaimer. So with that, I'm going to turn the screen over to Terry and let him take it away.
Okay. Thanks, Maureen. I get set up here. I'm hoping everybody can see the screen, and we'll be ready to go here. But welcome, everybody. Thanks for taking time out of your afternoon to join us for the webinar. And as Maureen said, any reliability program where you're trying to extend the equipment life and make those components last longer, you have to have a good lubrication excellence program built around that. A lot of good webinars, done by Discase and Noria and other people on this lubrication topic, and all of them have great information to help build your programs and improve your reliability process. A little bit about me, just a brief slide here for some of you that haven't been on the webinar when I've been on before, but a lot of different things we do in reliable process solutions. We do some RCM analysis, we do some training on predictive and proactive maintenance techniques. We've been doing a lot of lubrication audits over the past couple of years, and a lot of lubrication excellence training at individual plants and with webinars. But again, very important. Companies are realizing the importance of lubrication more and more every year. And then some other things we do in the company. We have some other training. We have asset criticality software. We build some plug-and-play lube storage room, and build a lot of different custom lube filtration equipment now. So, all in the efforts of helping companies make those components and that equipment last longer. And by doing that, you're decreasing the cost of failure and the cost of that downtime. Again, I always show my performance failure curve here. And you can see over on the left-hand side, when you get in the proactive area, we've got lubrication at the top. I came from Cargill, and one of the things we found out, and we started doing a lot of predictive technology, started doing a lot of precision alignment, precision balance, buying this select equipment. But we found out early on, if you do all these precision tests, we perfectly align a component. We use a balanced rotor in a motor. We use a balanced impeller on a pump or a fan. But the first time a maintenance person goes over there and dumps a dirty lubricant into that component, you're still going to have a failure, and sometimes a failure at an earlier point than you really wanted to. So the lubrication became one of the key things we looked at Cargill, and the key thing that I teach now to companies. We have to do this lubrication step correctly. The big question is there a payback in doing this, and how do you justify a payback? And again, as I look at some of the payback things that are the payback calculation slides that I put in there today, they're kind of a little bit subjective, kind of generalities, but through the course of the last few years in doing this lubrication process with companies, we've seen some major improvements in life cycle cost. One of the ones I'll talk about is a company, I can't mention the name, but they make roofing shingles for the industry. And that company there was experiencing bearing failures on some of their equipment where they had high temperature, where they had water issues. And of course, when you're making roofing shingles with the gravel and the things you're using on the shingles, you got high foreign material counts. Well, we took some bearings that were failing on their mean time between failure curves, around 8 months. We've got some of those bearings that have lasted 5 or 6 years now, just using lubrication excellence techniques. And some of the techniques we're using mechanical, or we're using the UE grease caddy and performer lubrication. We're using some synthetic lubricants now. We're using some automatic lubricators. All these things have taken this plant to reduce failures, and they're just moving this to every component in their operation now, and seeing some huge increases. But when you go to your managers, you go to big companies, and everybody's wanting to say, what is the return for the investment? How can I say that if I do this lube task, if I do all these extra steps, that it's going to make a piece of equipment last longer? So let's look at some of the things today, and look at how we can see if we can justify some of these things. So, I put this slide in here. There's many areas of lubrication excellence that, if performed well, can have a payback in the effort. And that's the key, is performed well. Now, an example, I was at a plant yesterday where we've done lubrication training. They've got a lubrication process going. They've set some measures and metrics up. And I'll show you a picture later on of a picture I just took yesterday of drums that were delivered to a plant. They were delivered the day before. It's pouring down raining that morning. The drums are all covered with water. I was there that whole day. When I left, I took another picture before I left. The water's still laying on the drum. So sometimes we have to look at the techniques we've learned and make sure that we're using all these lubrication excellence techniques to eliminate these failure modes we have in lubrication. So we have to do these things to prove that the process is going to work in the end. This is the statistic. We found out this at the company I worked for. We found out it at some other plants. I did a study at a power plant a few years ago, but it looks like in industries that have high particle counts or have high moisture, that about 50% of all rotating equipment failures in industrial plants are somehow lubrication related. So if you look at, I don't know if any of you have watched the 100 failure modes of lubrication that I put a couple webinars out over the past few years for UE and other companies. But if we look at all those failure modes, you'll see a lot of the issues we have with equipment failures are lubrication related. You're talking about dirty lubricants. We're talking about lubricants with moisture in there. We're talking about issues with the kind of lubricant, maybe the viscosity we're using. So there's a lot of different areas that a lube can cause the component to fail a lot earlier. So lubrication excellence, if we start at the very beginning of the process, it starts with the way we receive the lubes and the way we store the lubes. The lubes have to be stored out of the weather, out of direct sunlight. We don't want that drum heating up in the afternoon, getting the lubricant hot, and then if there's any moisture in the air, there's water on top of the drum. When that drum cools down in the evening, even though it's sealed and you say it's never been opened, it will eventually, over time, going through that cycle, you'll pull moisture into that oil, and there'll be moisture into the drum. Storing drums that have been open around any foreign material. So we have to eliminate the lube from exposure to these failure modes. So as I'm looking at this presentation here, we look at 5 major lubrication failure mode areas. Well, temperature's one. Lubricants that are running too hot, are going to oxidize a lot faster and become something that's not a lubricant. Moisture from the ambient air from maybe your process. A lot of food plants actually wash equipment down. Pharmaceutical plants do that, where you get moisture in from the washdown process. Foreign material. A lot of the industries I go into, the mining industry, steel plants and foundries, lots of exposure to foreign material and particles. Viscosity failures, something that it's a failure because sometimes people don't understand what this viscosity issue actually is. One of the main ones that I run into when I'm doing lube audits is some hydraulic manufacturer recommended ISO 46 for the lubricant in a hydraulic system. Well, ISO 46 may work in a certain temperature range, but if that hydraulic system's in a back corner, it's in a real hot area, the ISO 46 may get too thin. Or if that hydraulic unit's installed outside in an area where it gets cold, that viscosity may get too thick. And it's going to affect the performance and the wear of the components in the hydraulic system. And then contamination from things like glycol and other things that may be in your system that contaminate the lube. So those are the 5 major areas I look at in lube audits and doing lube training and trying to eliminate those issues at different facilities. So let's look at the payback for lube storage. Storing lubes in a controlled environment has a payback. The lubes can be filtered in that environment. All the particles and moisture taken out. When they're stored in a controlled environment, the lubes are stored away from foreign material and dust particles that are maybe in your facility. The lubes are stored away from moisture issues, out of the rain, out of the ambient conditions, out of high humidity. A lot of the plants that I visit during the summer in the Texas, Louisiana area along the coast, they're very, very high humidity in some of those areas. And it affects the lubricants if they're not stored in a controlled environment. One of the things that's a payback for lube storage, and we design and build a lot of lube rooms, not sometimes for the foreign material particles or the moisture, but it's good spill control. So environmentally, good lube storage areas won't let the lubricants out of those storage areas. Fire safe area. Lubricants are not very flammable. They have really high flash points. They're not really a fire hazard, but storing the lube in a room or a container where you have some fire or you have some safety with the issues of the fire, it's very important. But again, making sure the lubricants are in an ambient controlled area so they don't change temperature, they're not affected by the conditions around the lube. If you look at this picture, this is a lube storage area at a facility that I was at, and the lubes are stored in the maintenance shop. You can see all these products that are stored around the lubricants. This is filter aid and diatomaceous earth, all abrasive products, but they're stored. You can see the particles all over the drums, all over the containers, so not a real good storage area. The lubricants are exposed to all these conditions. Or if you look at this storage room here, it's an ambient controlled room. It's air conditioned, it's heated. The lubricants are stored in a spill pan. Here in this area here, there's not many hazards, not many conditions ambient-wise that are going to affect the lubes. We got desiccant breathers on all the containers. All the lubricants are filtered into the tank and can be recycled in the tanks. So a nice storage area. So what's the payback? How can you go into your managers and say, what's the payback if I want to put a clean storage area in? Well, it comes into less moisture issues like we talked about, less foreign material, less temperature changes in the drums. Storing drums outside. And sometimes I want to remind you that, who you buy your lubes from, you may want to go visit your lube supplier. One of the things that we do when we do our 2-day lube audits, we find out who you're buying your lubes from. We actually drive over there to see how they're stored in the drums. We found a number of them in the Texas area and out west. The drums are stored outside. They may be under a lean-to, but we found dust, moisture, and all kinds of things in the way your vendor stores the lubes. And we found some real good vendors that have the lubes inside. The rooms are heated, sometimes air conditioned where your lubes are stored, so it's going to make your lubricants be in better shape when they get them to the plant. Additives in your lubes are affected by temperature and moisture that get into the drums. So you could have a drum of oil sitting outside for 6 months to a year that gets a little bit of moisture in it, goes through some temperature changes, and all of a sudden you're losing additives. Your additives are being consumed by something else besides the equipment. Less additive dropout. Additive dropout is something that we found many years ago in testing the bottom of a drum. Find out there are some additives in your lubricants that settle to the bottom of that drum. And, if that drum sits there for a year or two and we go in and start pulling stuff out of the drum with just your basic old systems where you have a drop tube and you're pumping or hand pumping out of that drum, you're going to get more additives in the bottom. Unless there's a way to mix that drum up and remix those additives through the lube. This is done pretty easily in a lube storage room where you can recycle the tank monthly. I remember at Cargill, one of the practices of the lube storage room was every month you recirc the container, the 80-gallon or 100-gallon container for 20 minutes a month. which pulls those additives off the bottom and remixes them into the lubricant. So some good reasons for lube storage. Now, hard to put a number on this, but one of the numbers I put on here was at a plant in Texas I went to where the drums were stored outside. There was drums in the back that hadn't been used, and there was, just at that facility there was over $1,000 worth of lubricants that we had to dispose of that were no longer any good because of moisture issues. The additives were completely gone from the lubricant. Some of the lubricant had sat there and actually had a high tan number just due to oxidation setting in the sunlight in the summer, getting the rains in the afternoon, so lots of issues. So easily, if you're not storing your lubricants in a good, clean condition or inside, there's an easy $1,000 per year of savings. And I've been pretty conservative on my numbers. You'll see here, numbers are a lot higher at a lot of facilities that I visit. So now we talked about moisture. In nearly every plant or location I've been around the world, even in Egypt, moisture is an issue at some of these facilities and the way lubricants are stored and used in the plant. So the moisture can come from a number of different places: ambient conditions, rain, humidity, processed water, all kinds of ways that we can get moisture into the lubricant. But moisture affects the lubricating function of rotating components. If you get too much moisture, the viscosity is going to change. If the viscosity, or if you get moisture in there, sometimes you get so much moisture and the lubricant becomes something that's not even a lubricant anymore. And so when that happens, you lose that load capacity of the lube. Components start running closer. Components actually at some point start running together, and you're going to have some component failures, some component wear. Like we talked about earlier, that moisture has a huge effect on the additives that are in the lubricant. A lot of the additives are going to be consumed or change their characteristics if we have moisture in there, and the additive may not be of any value to you at all with the higher moistures. One of the big concerns here is in Texas, Louisiana, where we say we have the high humidity, you can actually have rust and corrosion on your internal compartments. I've seen a number of gearboxes taken apart in shops where the internal part of the upper housing is rusted. I've seen rust on bearings. I've seen rust on gears. That all comes from moisture. So making sure we have our lubricants with the additive package, which we'll talk about here in a minute, if that additive package has some rust and corrosion inhibitors in there and we're able to measure and track that, we can keep this rust from actually affecting our components in the inside of our housings. So again, it's going to reduce the capacity of your hydraulic system if we've got moisture in there. So lots of things that moisture does to our components. Here's a life extension chart here, and these charts are available in a little book that we have online that you can download, or we can send one to you. But if you look at the left-hand column here where you have 1,000 parts per million of moisture, if we follow that column across to the right and we go over to the number that says 50, that means if we can reduce our moisture level from 1,000 parts per million to 50 parts per million, we follow that line to the top, it's 6 times the life on your equipment. So moisture has a huge effect on the equipment and the life of the equipment. And to give you an example of what I've seen in plants, I was at a plant in Orange, Texas, probably about 8 years ago. I was looking at their lube analysis on a huge gearbox. It was probably a $400,000 gearbox. The parts per million of moisture in that lube analysis sample was 40,000 parts per million. The mean time between failure on that gearbox was 8 months. So we looked at some ways using nitrogen and getting that moisture out of the lube. We were able to reduce the moisture in that lubricant down to 1,000 parts per million over the course of about a week and a half with the nitrogen. But look what it does to the life factor of that, 9 times the life, which gets them up to what the normal life of that gearbox should be. It should be 8 or 9 years. I had experience with a number of these gearboxes in the company that I work for, and that's what we were shooting at for mean time between failure. So moisture in this system here had a huge effect on the life of the bearings and components in this unit. So since moisture and lubricating oils had an effect on lubricating qualities and equipment life, it's easy to see how much life's being lost. So you can see, if you're looking at lubricants, sometimes you see the lubricant word foamy or it starts changing in appearance. We can see moisture when it gets up to around 1,000 parts per million. It's very, very visible. But as we can see, that can reduce component life by 6 to 8 times. So again, some ways to put some numbers on this. How do we get it out? Well, desiccant breathers help keep it out. Making sure we understand how the desiccant breather works, making sure we change them as the color changes. If you look at the Descase breather on the right-hand side here, that desiccant that's in there is blue. As it starts absorbing moisture out of the air, that desiccant turns to red and eventually turns to white when it's completely exhausted. But when it's doing that, you see we're taking moisture out. And it also takes moisture out as the unit's breathing either direction. So these are excellent for keeping moisture out. Here's a system here made by Donaldson, and this is where you're using it's basically, in theory, an instrument air dryer, and you're basically taking dry air and bleeding it across the top of a hydraulic reservoir or across the top of a gearbox, and by bleeding that dry air across the top, if that unit's running, the moisture will leave the oil and actually go into the air where it can be exhausted. So the little example down the corner was 12 hours. There was a sample taken before we started at 1,320 parts per million. We let the dry air bleed across that hydraulic unit over the night and came back the next morning, and we were down to 18. So systems like this, using nitrogen as a blanket on top of, I use that a lot in turbines at power plants. Get the reservoir nitrogen blanket and keep the moisture out. It does a couple things. It keeps the moisture out. It also keeps air from being in contact with the oil, and it eliminates a lot of varnish that happens, because varnish has to have air in order to precipitate out. So you can eliminate a couple things with that. So what's some actions for moisture? Reduce moisture levels in new oil. Check your new oils, the way your vendor's storing them or the way you're storing them. You may be picking up moisture in your new oils before they're even put in the equipment. Eliminate moisture in your equipment with some good breathers. Eliminate moisture. One of the things I did teach some people at my plant where we use the power washer in the food area every night. Don't spray directly on the gearbox shaft. Don't spray directly on the motor shaft, because a lot of gearbox we took apart and they were just full of water. We've got to monitor the moisture levels. When the moisture gets too high, you have to either have a device to remove the moisture, or we got to have ways in there to replace the moisture if the lube gets too high. Better sealing methods, using desiccant breathers, using some devices to remove the air. Descase makes a vacuum dehydrator for big units where you can run the oil through a vacuum dehydrator and take the moisture out and reuse that oil. Lots of good methods. This was a picture. Sorry, the picture came out sideways, but this was a drum of oil sitting at one of my clients. I took this picture yesterday. This drum of oil was sitting there. It was raining all morning, and here you can see the water completely over the top of the vent cap. And again, these 4 drums were sitting out here when I got there at 7 in the morning when it was raining. This picture was taken in the afternoon after the rain was over, but really no effort there to get these drums in out of the weather, and make sure that moisture doesn't get in those drums. So lots of examples. So I put a little payback calculation here for moisture. So I just put this in if you have 50 pieces of equipment in your plant, and those pieces of equipment are running at over 500 parts per million of moisture. Reduce or eliminate that moisture can extend the equipment life by 4 times. If we just reduce that from 500 down to 50, you can go back to the chart and you'll see that's about 4 times. So let's say your average equipment cost per component is $1,000, which may be low, may be high, depending on the plant. Let's say the average repair cost per component is $300. This again can be higher or lower. Well, what if the average failure rate per those 50 components, let's say they fail 1 every 2 years? So of the 50 components, they fail 1 time in 2 years. So if you take 25 of those failures and we multiply that by that average repair cost per component of $300, you're talking about $7,500 here that we can eliminate, and that's pretty conservative. We can eliminate with just by reducing moisture in that equipment, whether it's gearboxes, whether it's hydraulic units, whether it's pumps, whatever the component may be. And this is not even assuming what your downtime cost is, because these downtime costs are widely varied through the industry. I've been at plants where the downtime cost may be $100 an hour, and I've been at plants where the downtime cost is $100,000 an hour. So you always have to put the cost of downtime in there. So tracking this information, getting these moistures reduced, and measuring this, you can find out what that actual cost of downtime is at your facility. Particles in a lubricant. This is this foreign material we talked about. New lubricants and drum has particles in it. We test a lot of new drums that the oil's dirty. Particles from your storage methods. What kind of containers are you storing the lube in at your plant? What about the lube transfer methods? Are you using oil-safe containers or the new Descase containers that they have out now to transfer the oil around the plant? Particles from the lube transfer equipment. I've been at plants where they're using water bottles, they're using Tide jugs, Downy jugs, any kind of jug they can find to take the oil around. Well, those are going to be dirty containers, and you're going to have particles in your process. Then you're going to have particles in the process if you're a fertilizer plant or a foundry. Those industries have particles that are in the air in all the equipment, so you're going to gain particle counts in those processes. And then eventually, if you keep those particles in there, you're going to have particles in your lube that are actually your components wearing out. I tell companies all the time in my oil analysis training, let's say you notice in your oil analysis sample that the particle counts are going up. At some point, as those particle counts going up, you're going to start seeing in your oil analysis that the steel or the iron number goes up, and then at some point you may see the tin number going up. When you see the iron and tin number going up, that's a direct indication you have bearing wear. And so a lot of times if we would have filtered that oil early on, when it just started getting dirty or just started getting high particle counts, we would have never seen the steel and iron or the steel and tin particles, the iron and tin particles, we would have never seen those numbers increase. So that's the importance of keeping the particles out by filtration, by changing the oil, and making the components last longer life cycles. Oops, I got a slide in there that's out of position there, but foreign material particles. So understand that loaded bearings and gears, people say, well, how big a particle can be before it can cause damage? Well, if you take a loaded bearings and loaded gears, that film thickness in that loaded bearing or loaded gear is going to be around 5 microns. So I tell people if the component's heavily loaded, that may go down to 3 microns. If it's lightly loaded, it may skim on a little bit heavier film of oil, may go up to 10 microns. But if you check a lot of your new lubricants, you're going to find out there's 25 and 40 micron particles present in the new lubes a lot of times. So if you look at plants, there's millions of particles in our lubes and our lube equipment that are over that 5 micron range. So how big's a micron? Well, it says here bacteria is around 3 microns. Red blood cells are around 5 microns. Talcum powder is around 10 microns. That fine floor dust that you get if you go run your finger across the door seal at your house, unless you're at Marine's house, you're going to find 40 and 50 micron particles on there. That dust that you're getting off the fans in your plant, off of handrails, I've been at coal plants where everything you touch, you have that fine dust. Those are 40 and 50 micron particles. So in that film thickness of the loaded gear, those are boulders going through there. So that gives you some idea of the particles we have to get out of the lubricants in order to get this long life. It says here the human hair is 70 to 80 microns in diameter. So you can see the particles that are causing this wear, causing this damage, are particles that we can barely see. And those are the particles we need to concentrate on getting out. So it's these particles over 5 microns that's causing this wear. Well, I'm going to show you a few slides on the ISO codes here for some that don't know what those codes mean. Most of you probably do if you're into lubrication, but this ISO 4406 cleanliness code, it was a code to develop to help us understand what these particles are and how big they are and how many, basically how many of them there are in your lube oil. So it's a 3-digit series, and this is an example here of 21, 19, 15. So that first number, the 21, represents a number of particles that are larger than 4 microns, and in that 1 milliliter sample. The 19 number is the particles that are larger than 6 microns in that sample. And the 15 number are the number of particles in the sample that are larger than 14 microns. Now these are the ones a lot of times that are causing the most damage, because larger than 14 microns means they could be 25, 50, or 100 microns in size. So we really don't know unless we run some extra tests. But the 21 number actually means, it doesn't mean there's 21 particles in that milliliter sample. It means there's somewhere between 10 and 20,000 particles that are larger than 4 microns. So if we look at this slide example here, the 21 number, if you follow that across, there's somewhere between 10 and 20,000 particles in this oil sample that are larger than 4 microns. The 19 number tells us there's somewhere between 2,500 and 5,000 particles that are larger than 6 microns. And the 15 number, if we go down to that spot on the ISO code, means there's somewhere between 160 and 320 particles that are larger than 14 microns. These are those major wear particles. But this is in a 1 milliliter sample, so that's about the size of a WD-40 cap. So it gives you some idea when you do a lube sample of your container how many particles are actually in a drum of oil or a bucket of oil. There's millions and millions of particles in there. And if we're not cleaning our oil up, we're dumping those millions and millions of particles into our components, and that's causing our components to wear and fail a lot faster. So we have to concentrate on these 14 micron particles and get as many of those filtered out as we can. So here's just a chart. If you look at the right side of this chart, here's some ISO codes. If we go down to the fourth box down on the right-hand side, it's a 21, 19, 17, but look at the particle counts in the different ranges. Now, as we filter our oil down, if we go up to the very top on the 17, 15, 12, which is what we try to achieve or better when we try to do lubrication excellence at a facility, look at the number of particles that we reduce in our 14 micron number down to 20 to 40. Then as we lower this number down to a 16, 14, 11, or we get down to those lower micron particles, we reduce these big particles that cause wear. And the thing that happens is we start eliminating wear in our components. Your components start lasting longer life cycles. Here's a slide here, and this is what I had to do with my maintenance people to get them to understand visually what's going on. I had them look at a couple bottles of oil. The one on the left, you could actually see no particles in it. I actually looked at it myself. It looked clean. But this was the ISO code of that oil when we sent it in and had it checked. It's a 22, 19, 17. This is what it looked like magnified 100 times. Now we filtered that oil through a 10 micron beta 1000 filter. This is what the ISO code came back, and this is what it looked like on the slide on the right. So you can see from just looking at these two slides how much longer the equipment components will last if we keep the oil at that cleanliness level. Now this was in a gearbox at a coal-fired power plant. These are fly ash particles, all kinds of wear particles in here. But all these particles you see on this slide you can't see with the human eye. But again, they're going through your bearings and gears hundreds of times a day. So if you take a typical hydraulic system, let's look at on the left-hand side, this is our dirty oil side down the left-hand side. If we look at the 22, 19, 17, we follow that across to the right to the line that says 16, 13, 11. For a hydraulic system, it's around 5 times more life just filtering the particles out of the oil. And you can see as we filter down even farther, let's say we go down to a 13, 10, 8, which may be down around a 3 micron beta 1000 filter or beta 2000 filter, you can see we gain 10 times the life on the hydraulic components. Now, I know this slide is true because at the facility I came from, we actually had some hydraulic systems. We filtered them down to these levels, and I think the first pump failed after 9 years. So we know these ISO codes and this lube filtration actually works at that facility. I've got many, many other examples from other companies around the U.S. where they're seeing these kind of results. Here's a gearbox life extension chart. Not quite as dramatic as the hydraulic. You see the 22, 19, 17. You go to your 16, 13, 11 column 2.5 times. Now I'm actually seeing filter into that level, that 10 micron beta 1000 level. I've actually got some companies now that are up in 3 and 4 years at that filtration level because we're able to get it there and keep it there and maintain it there. So these companies are thinking they're going to get 6 to 7 to 8 times the life just with this 10 micron beta 1000, which is at 16, 13, 12, 16, 13, 11 range. Excellent results. But what kind of things do we see? Here's some very expensive, some very high quality lubricants, and this is what I see at a plant. These are greases. And these expensive greases, and you can see the grease gun completely covered with dust. And I actually watched an operator go over there and grab this grease gun without wiping it off, stick this on a greaser, and start greasing a bearing. Now these components, when we pump all those particles into even a grease bearing, and we're getting particles into the grease and around the grease gun, are going to cause the components to fail a lot early. Now this particular plant, we took the grease gun application away from the employees. We put auto lubers on there that automatically lube with synthetic grease. This is the company here that saw the failures of 8 months go to 5 or 6 years. So these processes do work. There's good data out there on lubrication excellence. So where do the foreign material particles come from? Well, ambient conditions in your plant. You saw the plant in the last picture. Lots of dust, lots of dirt. Contaminated new oil. And you can just go down the list here. Some of the things we've talked about. Not having breathers, particles in new grease, the way we store the lubes, the way we take it around the plant. So lots of things contribute to the condition that our lubes are going to be in and the dirtiness your lubes are going to be in when you take it to the equipment. So again, I went through this same calculation here. The number comes out the same. Like I said, it's kind of, I just have to guess sometimes. But if we look at the plant here and we say we're going to go from a 22, 21, 19, and we filter that all the way down to a 16, 15, 13, I think if you follow the line across, you're looking at 6 times the life. So again, if you go through this same calculation, we say the same cost, the same number of components fail, but now they're failing because of particle counts and not moisture. You're still looking at a number that's very similar. So just with these small components here, we're looking at another $7,500 savings. But again, what's the cost of downtime? What's the actual cost of repair? I really don't know that. But a lot of plants are actually calculating this. We're putting in new bearings and new gearboxes. We're putting in these perfectly clean lubes and trying to keep them that way. You can see if the gearbox originally lasted 2 years, we have to let that gearbox run now for long periods of time and measure it. And one of the key things we're using at some of the plants is just listen to a mechanical ultrasound, and that's the earliest detection of bearing wear and bearing failures, and we're finding that we're not having any noise for years and years and years. So, cleaning the particles out. And if you put both these together, if you have moisture and particles at your plant, you can see we're going to double this number. Temperature failure modes, we'll go through those real quick. Your oils, especially when you're using petroleum-based, mineral-based oils, temperature has a huge effect. It changes the viscosity. It causes the oil to oxidize a lot faster. It causes the hotter oil has something called hydrolysis, where it's more susceptible to mix with water. Some of the thermal conditions, sunlight, the ambient temperature at your plant, heat off the process. I was at a mine and I was asking them why they were using ISO 1000 oil in a gearbox. I said, man, the oil is really thick. It's hard to filter. Where would you be using ISO 1000? Well, when I went out in the facility, the gearbox was mounted under some big rotary kilns that didn't have insulation on it. It was too hot to even stand there. I mean, the temperature close to the gearbox, even in ambient when you're standing there, had to have been well around 120, 130 degrees. And it was on a cool day. I don't know what it was like in there in the summer, but that viscosity changed, and that's why they had to use the thicker oil. So lots of temperature failure modes. But again, here, for a petroleum-based oil, the life is cut in half for every 20-degree rise in temperature. So if you look at this chart, let's say you've got a condition in your plant where the gearbox, hydraulic unit, whatever the component is, operates at 70 degrees Fahrenheit, and we say we keep all the moisture out. That lubricant will last about 30 years before it oxidizes. But as you go down this temperature scale right here, you can see what happens as the oil gets hotter. It oxidizes a lot faster. And like I said, the point to make here is that assumes you don't have any moisture in there. If you have moisture in there, it's going to change, it's going to lower these numbers, it's going to oxidize even faster. So again, find out where the temperature is coming from. Try to eliminate the temperature issues, monitor those temps, may have to change oil, change viscosities to eliminate some of the failure mode issues. So, reduce the temperature with cooling. Change the lubricant more often. Watch for the signs of oxidation. If you're not doing oil analysis, sometimes just take a sample of the oil when you put it in and put it in a jar and watch it over the course of 3 months. Once it gets real dark, just like your engine oil. If you look at your dipstick on your new engine oil, it's clear, kind of a gold color. As it oxidizes, it gets darker and darker. Eventually it turns black. Well, when it gets dark, really dark, it has very little lubricating capability, so your engine's going to wear a lot faster. Synthetics are better in temperature modes. We're going to have a few slides on those in a minute, but we have to eliminate these temperature failure modes. I didn't put a number on that one, but some of you, as you go around your plants, could probably see if you've got oils oxidized, there's probably a payback in that one. Making sure you understand what additives are in your oil, because your additives are going to deplete over time and cause the lubricant to fail. So we got to watch the additives, and we got to do sampling to make sure the additives are still in there. I put this slide in here, some of the common additives that are in lubricating oils, anti-foam and hydraulic oils, dispersants in engine oils, EP additives in a lot of your gear oils. Detergents are in all your engine oils. Your anti-wear agents, a lot like your EP additives, they're in there to protect the component from wear. You can see on the right-hand slide corrosion inhibitors, rust inhibitors, which we should be using in the high humidity areas along the coast. Oxidation inhibitors, which keep the petroleum-based oils from oxidizing, all very important, and we all have to do measurements on those to find out if those additives are still in our lubes. If you want to do a webinar someday on additives, we'll spend some time on that so everybody understands what they are, how to check for them, and what the importance of them is, how they make your equipment last longer. We talked about viscosity. failures. Remember, in petroleum oils, as the temperature goes up, the viscosity goes down. And I did a training presentation at a plant where we looked at ISO 150 oil. It's ISO 150 at 104 degrees Fahrenheit. These gearboxes in the plant were actually running 150 degrees, which took the ISO viscosity code down around in the low 40s, high 30s. So they weren't getting the protection at that temperature they needed, so we had to go with a higher viscosity oil. You know, mixing, oxidation increases viscosity. Too much additives, too little additives, so lots of things affects viscosity failures in our lubricants. But again, we must understand it, make sure we're using the right viscosity in the right location or a plant so we don't have that equipment wear. Now, one thing I wanted to talk about here is a payback. A lot of people, when I go to plants, they're not using synthetic lubricants because they cost too much. You know, synthetic lubricants sometimes cost 3, 4, 5 times the cost of your lubricant. But they have some paybacks in the way you use synthetic lubricants. Well, first of all, they have higher thermal and oxidation stability, which means the synthetic lubricant running at a high temperature will last 3 to 5 times longer before it oxidizes. So they take temperature much, much better. If you're in cold areas, you know, I was at a plant in Canada one time where every spring they went out and put heavy oil in the gearboxes. Every fall they put light oil in there. Well, there was a loss of oil. There was all kinds of exposure of the oil. We just switched it to synthetics because it has that lower pour point. It doesn't get thick in the wintertime when you get these minus 20, minus 30 temps. It has lower volatility, which means it's less susceptible to catch on fire. It has less foaming characteristics because it doesn't mix with water as readily. So that's one of the reasons a lot of times in hydraulic units you see the foaming and the bubbles. There could be 2 reasons for that. You're out of anti-foam in the oil, or you have moisture in there and the oil's mixing with the moisture. It's longer lube life, longer equipment life. You know, it's been proven in many, many industries and many, many different tests that I've done that your equipment life is going to last much, much longer with synthetics over petroleum-based oils. And then a big one in a lot of facilities now is what do you do with your used oil? Well, most of the time we have to hire somebody to come and pick it up. They come in and they charge you to take the oil away. Now, what they do with it, a lot of times we don't know. Some people recycle it, some people burn it in heaters, but it costs you to have that oil hauled away. If you're using synthetics and they last 3 to 5 times longer, your disposal costs actually go down. So that's another advantage. So lots of advantage to synthetic lubricants. Why are they better lubricants? Well, if you look at this slide, if you see petroleum oil on the bottom here, well, these are not particles in the petroleum oil. These are the molecules that make up the petroleum oil. And what it's trying to show here that the molecular structure of the petroleum oil, the molecules are not all the same size. So yeah, it makes a lubricant. It makes a kind of an effective lubricant. But if we look at synthetic oil where the molecules are all the exact same size, we get better loading capabilities, we get less friction, and the synthetic oil becomes a better lubricant. So that's the easiest way to explain why synthetics are better than petroleum-based products. One of the big keys, I just wanted to bring this up because it comes up all the time, that if I'm using a petroleum-based product, I've got to clean it all out. I can't have any cross-contamination with the synthetic. As long as you use the PAO, the polyalphaline oil, those will readily mix with mineral-based oils. So you don't have to worry about completely taking everything out. You can mix them 50-50. You can just drain the oil out, put this in. The same way with greases. As long as you're using a grease with a PAO synthetic, you can start greasing a component that has mineral-based lubes in it, and you won't have any issues. Now, any of the other synthetics on here, like your polyalkylene glycols, your PAGs, commonly used in air compressors, none of these synthetics down below the PAO will mix in any form or any concentration with mineral base. And if you ever take a compressor oil out and it looks like tapioca or cottage cheese, you see the little balls in there, somebody has put mineral-based oil in your synthetic or mixed it in a jug somehow. So that's one of the first signs I see at plants of semi-samples. What causes this? Well, I know right away that a maintenance person has put some mineral-based oil into an air compressor or something that had a non-PAO synthetic in it. Just some other information slides on here, you know, about some of the other synthetic products. I just put that in there for your information if you want to download the presentation. Some life comparisons you can see with mineral-based oils. We're talking about 1,500 to 2,000 hours. Your partial synthetic blends, if you're blending them yourself or buying them that way, 4,000 hours. Your PAOs, 8,000. your PAGs and esters 8,000, your POEs, which are very, very expensive synthetics, and a lot of times they're fire-resistant synthetics. You know, you can get up to 12,000 hours. But these synthetics are getting better and better all the time. I was with somebody from ExxonMobil yesterday, and they were telling about a new synthetic product they developed for turbines, and they tested it on a GE turbine, and it's only an ISO 18, but the performance of that new synthetic oil is far exceeds anything that's on the market right now. So ExxonMobil's tested this. It's going to be coming out probably in a year or so, but it's a new synthetic. So synthetics are getting better and better all the time to reduce wear and extend life. Here's something else as a payback for synthetic lubes. In 2002, and I'm trying to find the study. I have it somewhere, but a U.S. plant took all their equipment in their plant, and they measured energy usage on all the equipment in the plant for a 6-month time period. Excuse me. The plant had to shut down. They switched every lubricant in the plant to synthetic, greases and oils. That plant, even 2002, saw a 9.6% decrease in power consumption. Now, that's a huge number at a facility that has a lot of equipment. And like I said, since 2002, synthetics are even better. So there could be more energy savings here, which makes a huge payback for switching things to synthetic lubricants. And I'll try to find that study or direct you to that if you shoot me an email. I know I've got it somewhere. But again, some other operational failure modes, I threw these in by making sure your operators know what to look for when they're looking at lube failures. You know, if they see something foaming, if they see particles, or teach them to keep particles out. These are operational failure modes we have to control. So again, we talk about failure modes, some other training that we've done, so lots of failure modes. You know, not having a lubrication program, no wear particle analysis program. So you can see a lot of these I just put in here for your information from an earlier presentation, but all important things that you need to look at your facility as you're moving to lubrication excellence and some of the things you need to do with that process. So again, highly effective, huge payback in lubrication, and I'm hoping the kind of these broad range paybacks that I put in the presentation today kind of help you go to your managers and say there's a big benefit to doing lubrication excellence. Because we have to, like this slide here, we have to move from doing this reactive things on the left side of this curve over to doing the things in the proactive and predictive part in order to make our equipment last longer. So if there's any questions at this time, Maureen, we can take a few questions. If anybody wants a copy of the presentation, you know, you'll have it, I'll also have it.
All right. Well, thanks, Terry. That was great, and I appreciate your vote of confidence on the amount of dust in my house. I promise it's there. Anyway, but yeah, so definitely some questions coming in.
Okay.
So, you know, just kind of first, in this kind of a common theme was some of the things folks are writing in, but you know, anytime at least I hear these presentations on lubrication excellence and these kinds of things that you can be doing, it always strikes me that it just seems to be just such low-hanging fruit, just kind of not necessarily, I'm sure that, you know, there's obviously cost and effort that goes into it, but it just seems like it's just such a simple win and a huge win for folks that implement these things. So why is it, you know, what do you see and what are the reasons why people, you know, don't just jump on this right away? And then what are some of the kind of suggestions you could give those folks who are, you know, beating their head against the wall trying to get these things, you know, approved and moving at their facilities? What do you say to those folks to kind of maybe give them that extra argument to get these things moving?
Yeah, one of the biggest issues I see going around doing lube audits is people are doing lubrication excellence. They write some procedures, but the biggest thing is there's a lack of training at the technician level, the guy that's actually doing the lube task and handling the lubes. As I go around and ask questions, they're kind of unaware of some of the things that actually are important with this, because you know a lot of people, you know, greasing and changing lubes and taking around the buckets, and a lot of times with maintenance people, like I said with my guys, if they can't see it, it's not there. So that was a huge issue to get that across so they can visually see some of these things. Actually cutting filters apart off of filter carts and looking at all the particles on the filter was a big one for a couple plants I went to. We went out and filtered a gearbox. We took a cutter, we cut the filter apart, and we pulled the filter housing off so we could see the filter, and they were amazed at the amount of particles out of a gearbox that they thought was relatively clean. So it's the training concept and getting that training down to that level.
All right. And So, then assuming someone's, gets kind of to that point where they're able to start doing some of these things, what's kind of your best suggestion for kind of where to start? Do they start, with their supplier, trying to improve things there? Do they start with the lubricant they've already got in their in-house? What's kind of the suggestion as far as that's concerned?
Well, the key thing there is was one of my big customers. They have a little oil analysis lab at their plant, which most people don't have. But they started going through their vendors. They told their vendor what they wanted for ISO codes of the new oils coming in. And so the first vendor comes in, they test his oil right in the drums on the cart, or as the truck was delivering them. The oils were dirty. They sent the oils back and didn't buy anything else from them. So they went through their third vendor before these vendors figured out I better clean this oil up. So start with your supplier, because that's where a lot of particles, moisture may be coming from. Start with your practices as far as how you're storing and how you're taking care of it. Move into how you're moving it around the facility. But again, developing some procedures on how you're going to receive it, store it, apply it, and then what these filtration limits need to get to, because you can't really get them with a new vendor most of the time unless you go to synthetics, which synthetics are cleaner. But I've seen people go to synthetics and the guy still goes up there and takes a Tide jug and he takes the synthetic lube out and dumps it in the equipment, and using a dirty funnel. So it's starting at the beginning, getting things clean at the beginning, then working all the way down to that application step. So it's a big process.
It must drive you nuts when you see some of these things out there. I'm sure you've just got stories upon stories. All right, so let's see, a couple more here coming in. Do you have any recommendations for removing dissolved water in oil, for instance, like in the gearbox?
Yeah, the biggest one is that there's filters made, disc case, and it makes them and we sell them, but there's desiccant filters for when you kidney loop your box that'll take moisture out. Like we talked about the instrument air dryer you can buy, and bleeding dry air across the top of a gearbox and letting it slowly vent out. The moisture will come out of the oil and go into the dry air. Nitrogen actually works. If you've got a nitrogen supply, your plant bleed just a little bit of nitrogen on the airspace of that gearbox, and nitrogen's very dry, and moisture will leave the lubricant and go into the nitrogen. But once the oil's changed to it's went through this hydrolysis step, a lot of times it's hard to get the moisture out. So if you let it go too long, it's almost impossible to get out without just changing the oil.
All right. Well, and that kind of leads into the next question. If the lubricant I have that has already been stored and transported incorrectly, is it beyond repair? Do I just immediately need to chuck it, or are there things that we can do to try and rescue, breathe new life into some of these things?
Yeah, and that's the purpose of filter cards, because a lot of times the oil is still good, but it'll have a high particle count or it'll have high moisture. Or the additives. I mean, a lot of people throw good oil away because the additive package is gone, which up till just recently here, that's been the only option. But there are additive packages you can add now. There's all kinds of filters that we can kidney loop gearboxes and hydraulic systems in the facility to take the particle and moisture out. So there's all kinds of things we can do to keep that oil, because a lot of times there's nothing wrong with the lubricant. It's just all the things we put in the lubricant that make it bad.
All right. What do you know about bearing, fluting, burning oil?
Bearing, fluting, burning oil. I'm not 100%
Okay.
sure what that.
All right. Well, if the person who asked that, if maybe you can explain more what you're looking for. Sorry, Terry, I didn't mean to throw you a curveball there. All right. So how about this one then? Are there special storage and care requirements for food grade lubricants?
Yeah, it's the same for food grade lubricants. They can have high particle counts. They can also attract moisture, but once you get moisture in a food grade lube, it biodegrades a lot faster. So food grade lubes are very susceptible to biodegradation, because once they come in contact with air, if they're heated up, they oxidize a lot faster. If you get any moisture in them at all, they oxidize a lot faster. So food lubricants normally aren't as good a lubricant anyway to begin with. Some of your new synthetic food lubricants are a lot better, but the problem with food lubricants is the things that cause them to biodegrade earlier and oxidize earlier, and that's temperature, that's moisture, and any contamination you get in there is going to cause them to oxidize much higher rate.
All right. Well, I think that's what we've got for now. If some other folks want to type some questions in, we can get those to Terry offline and you see you've got Terry's email address there, and I can obviously share that with you all, if you need it. So just so everybody knows, they can get in touch with you. So I'm going to take the screen back here, Terry, and I've got a couple closing slides to share. So we'll kind of pop through here real quick. So, thanks again to Terry. This great information. As I mentioned at the beginning, Terry has done a few of these webinars for us, different topics. So definitely, you can check our website, uesystems.com, to see those recordings. We've got some articles that we've got from Terry, so lots of good information in regards to lubrication. So definitely check out what we've got online there. And of course, we don't just talk about lubrication. We've got information about all the other applications on there as well. So hopefully if there's something you're looking for, we're hoping we're a good resource for you. And if you're looking for something that you can't find, just let us know. And I'm sure we know someone like Terry that can help us out and get that information for you. Would love for you to stay connected with us in between these webinars. We've got our UltraProbe users group, or our Reliable Asset World users group. Great place to ask questions, share advice, commiserate, whatever you need to do. It's a good little community that we've got over there in LinkedIn to kind of banter back and forth with your peers throughout the globe. So check those out. You can follow us on Twitter. We're constantly pushing out different articles and resources that we find, not just from our own website, but obviously we're kind of cultivating that information throughout the internet and so forth. So check that out as a good resource, and save the dates. So our lubrication month, Lubriary, continues next week. Adrian Messer is going to be presenting on ultrasound assisted lubrication. So now getting pretty specific to how you can utilize ultrasound to assist in your lubrication program. And Terry mentioned some of that in his presentation, but Adrian will dive a little bit deeper into that. So that's next Thursday from 1 to 2. We'll get an invite out to everybody about that, so if you're interested. And then our conferences, which Terry will be presenting at as well. We're going to be down in Clearwater Beach, Florida, May 10th through the 13th, with our Ultrasound World and our Reliable Asset World conferences co-located down there. Great conferences, great venue. You can't beat Clearwater Beach. It's gorgeous. The content is always top notch, and just a really good place to network and get to know some folks that can be good people to put on speed dial when you've got questions and need some advice on things like the topic we had today. So hopefully folks can join us down there. We'd love to have you. And with that, we'll leave the contact information up here. We thank you everybody for joining us. Thanks again to Terry, and everybody have a great rest of the day.